This is the continuation of the previous video where I showed you how the slot 1 algorithm works. In this video I'm going to show you one more way how the slot 1 algorithm is used. Here we are going to use the part of the UID we know, and bear in mind the slot 1 algorithm is meant for a single tag activation or single tag read and write. In other words, when there's only one tag in front of the reader writer. Now I know this the UID of this tag, so I have written on the tag. However, it's very easy to find out from this screen. Just click on the get system info, and I just want to repeat what exactly has happened. So keep in mind the ISO 15693 tags doesn't need a separate activation step like the MIFARE or the any 1443 type tags. They are ready to talk to the reader. Now this command, you can see here, the UID of the tag is E0, 04 and so on. So I'll be focusing on the UID at the end of this number, that's 44D772. Okay, so we now know the UID. So let's try to understand how the slot 1 algorithm can be used knowing the UID. So I'm going to take this out again. Probably the best thing is to start this screen. Now we are going to use the slot 1, so that is selected, and we are going to use the mask length and the mask value. If you remember the inventory command structure, it has the mask length and mask value. So I'm going to use a simple mask value here, otherwise we'll end up using a calculator and start working on the bits. So I'm going to use the mask length as 4. Now what I'm trying to tell here is, so I'm looking for, I'm trying to compare, or I'm interested the last 4 bit of the UID. I think the best is probably to show you the document, and probably once we see the diagram we'll come back to the screen. Now I thought of showing you this diagram when I discussed the slot 16 method, but now it's good that you understand what this does, and with this knowledge probably you can understand the slot 1 what I'm going to show you now. So here this is exactly how the tags are selected to build the inventory. Now at the bottom here, this is the UID of the tag, which is 64 bits, starting from the most significant bit and the least significant bit, and the most significant bit is that E0 thingy. So the inventory command sends 2 bits of information. One is the mask length and the mask value itself. And this diagram is applicable for slot 16 because we are discussing using slot 1, so we can ignore this slot number. So you can just ignore this for the time being. So the inventory command is trying to send the mask value, and that mask value is compared with the lowest bits of the UID. If they match, so the tag will be selected in the inventory process. So yeah, just what we're trying to say is the mask value in the inventory command is compared with the last bits of the actual UID. If the tag matches, because see, this comparison is done by the tag itself. So if the tag matches the mask value, then the tag will respond with its UID, and we know that DSF ID as well. Now when the mask value is sent, the inventory command also tells about the mask length. So it tells how many bits of the UID the mask is going to compare. Now this is if you read this probably a couple of times, you'll understand. However, I'm going to come back to this this diagram, when I discuss about the slot 16. Now I'm going to say that the mask length is 4, and because the mask length is 4, I have to put only, this is the mask length is in the bits, it's a 4-bit value, so I'm going to say that I want 4. So because I know that this tag, the last byte of this tag is 4, and if I click inventory now, you can see that, see the command structure. The 26, we have seen this before. 01 is the inventory command code, 04 is the mask length, and this is actually the mask value. So the mask length tells the mask value is 4 bits. However, you cannot just send 4 bits, you have to pad enough zeros to make it a single byte or 8 bits. That's exactly what is mentioned in this document as well. Now somewhere, if you go a little bit up, yeah, that's what it's this is a good example here as well. Say if the mask length is 12 bits, so which is not a multiple of 8, the remaining 4 bits to make 16 bits is padded with 0. That's exactly what's happening in the command also. Now what has happened here? So the inventory command tells it is interested in all the cards where the last 4 bits matches 4. This is exactly what this tag is. I have got one more tag here where, say for example, this is the target. So I know that the last 4 bits of this tag is 2. Let's see what's going to happen when I use the same command structure. Now here there is no response. The reason is this tag did not match the last 4 bits as 4. So if I make it as 2 and issue this command, look at that, how cool is that? So the tag got selected. So we can try just understand this concept. I got one more tag. This has got the last 2 bytes as C and 9. If I try to use this tag, obviously should not respond. If I use say 8, doesn't respond. If I use 9, that should 100% respond. Now look at that, you got the response. You can increase this number of bits as well. So I'm going to try this time with 8 bits. Now I know this tag, the last 8 bits are 44. Now first thing you do is the mask length is 08 and the mask value is 44. Try 43 first. Clear the screen. Inventory, the tag did not respond because what the tag did was it compared 43 with its own last 8 bits of the UID. Because they did not match, the tag did not respond at all. Now I'm going to change this to 44 and hit the inventory. The tag responded now. See, that's the this the one thing I liked about this board and this software is it's very easy for developers like me or you or any students to understand all these ISO commands. Whereas in some readers you will never get a direct control like this. So even if you get a control, okay, the way you're trying to use may be more complicated. So that's a good thing about this board. Okay, so what about the higher bits? I want to compare, just if you want to get some more comfort in this command, I'm going to try this one. This ends with the C9, so 44 doesn't match. Try C9, inventory, it matches. That's it. How about if I want to compare with the last 12 bits? So 12 is 0C, the length, and As soon as you type 0C, you get an additional text box here. Now this, the UID of this tag is 08. It's 08 here, so I have to match 0C9. This the last three nibbles. It's 12 bits. Now I would put, I can't put exactly 12 bits here because the software automatically converts this to multiples of 8 bits, and I'm going to clear it. Probably not, just going to take it out and try again. Now try with the incorrect value C8. Will this work? Keep an eye on the command structure also. 0106 is the mask length and this is the mask value, and when the mask value is sent, when you start sending these commands using your program, make sure you send the lower byte first followed by higher byte. Now C9 is wrong, try with the C8 is wrong, try with C9. Inventory, look at that, how cool is that? You got it. Now you learned how to select with 12 bits. Try one more, go with 16 bits. This time I'm going to try the other tag. I know this tag has got 7D44. Now I know this is higher byte is 7D and the lower byte is try this. You should get error message. Try 7D and 44. Inventory, look at that. So this command we are using the last 16 bits to select. So whatever you have learned in slot 1, that knowledge is also required when you start discussing about a slot 16. Now how about the 20 more than 16 bits? Say for example I want 20 bits, so 16 and 4. So you can try add some more bits here. So here the mask length is 20 bits. This is in hex number 20 bits. So I have to enter the last 4 gives me 8, 7D gives me 16 bits, and the 2 nibble gives me 20. So this has to be 2. I'm going to try with the 1 first. Probably now. Replace the tag again. 01 inventory didn't work, so I'm going to choose 02 inventory. Look at that, you got it. Try, I can just keep on trying up to the 64 bits where you'll be using everything from here. I'm not sure whether this software will go up to 64. Let's try with the next phase 24. So this is 16 plus 8, 24, and 24, I have to include 2 and 7. Up to 7 to 70, I just have to increase here 7 to. Just going to replace this. Inventory, look at that, it's able to select. How about going with the 30. Okay, we're going to try with the 28, so that will be 1C. Now, so I need to know one more the nibble from the next byte, that is B here. I'm going to put B. So the mask length is 28 bits and the data is 28 bit value. I'm going to enter a wrong, incorrect value and try first. Sorry, not here. This makes no difference. Sorry, it has to be. I'm going to make this as A first. Okay, so it did not match. Try B, and it matched. So we're able to match the 28. Next, you can try the 32 bits. and here we just have to complete this entire byte here, 6B. So 6B, probably I'm going to try with the 5B. Inventory didn't work, so try the exact value 6B. It worked. Okay, so now this is how the mask value works. You can keep on trying this until you go up to 64. But again, the question most people will ask is, when do we use these type of things, like setting the mask value 20, and here probably my answer would be, if I have to use a single slot method, probably now I will not use this mask value at all. I'm just going to set this to 0, and I know I'm just always accessing single card. Whatever card is there, I will get activated and start read and write. Or to make it more secure, probably I will go with the AFI as well. So I'll be interested in cards of only certain type. So let's see if I can give an example where this mask length is 64. So probably now I just have to start a little bit of a binary arithmetic here. Okay, so what I have done is I have set the mask length to hex 40, which is a 64-bit. So I have to key in all the 64 bits of the UID, and let's go and try inventory. So look at that, we got the response. So what exactly has happened here? The tag compared all the 64 bits with its own UID, and because it matched, it responded with the DSF ID and that. Now to make sure, okay, it worked, we know it worked, so there's no point in a second thought here. Just play with this number. Now I'm going to use 43. Inventory didn't work, and 44 inventory, it worked. Okay, and that's all about slot 1 method of anti-collision. And in the next video I'll be showing you how to do the slot 16, and I'm 100% sure the next video will be easier, because most of the basics of the important concept we already looked and we already learned in this slot 1 method. Thank you.